right, hey there, coming at you from West Virginia. Doesn't it look like it? Anyways, let's take a look at joke of the day, because it's the best part of the day. So why does Waldo always wear stripes? Because he doesn't want to be spotted. All right, so let's spot some quadratic functions. We've looked at the simplest case of a quadratic function. We've looked at the standard form of a quadratic function, and now we're going to look at the general form of a quadratic function. General form looks like this. Remember that f of x is acting like a y. Notice that we have no parentheses in this one. So I'm not going to be able, I'm not going to be able to eyeball and get that vertex. But what I can do is I can take this function here and I can complete the square on the function. If I complete the square, it will end up looking like that standard form. And remember, that standard form looks like this. We have an a x minus h. Well, let me rewrite that. That's not very good. Okay, standard form look like this, where I have an a and then an x minus h squared plus a k. And what will happen is, if I take this and I do that process of completing the square on it, what will sit right here at this h will be a negative b over 2a. So in other words, I will have the opposite of this coefficient divided by 2 times that coefficient, and that will become this h. And remember, the h, being that it's applied to this x, that will be the x coordinate of the vertex. Now, I can show you a beautiful demonstration of completing the square on this to be able to come with that. Most people don't want to see that, so I'll spare you it. You just need to trust me that that is the process that gets you the x coordinate of the vertex. Now, you're smart people. Let's think about this. If this is the x coordinate of the vertex, what would it take to get the y coordinate of the vertex? In other words, if I knew that that x, say for instance, was a 5, then what would I do with that 5 to figure out this y coordinate right here? You're exactly right. Take that 5, plug it into this equation, follow order all those order of operations, that will spit that y value out, which this is representing a y. So in other words, once I know this, to get the y coordinate of the vertex, all I'm going to do at that point is I'm going to take that function, I'm going to put this where I see the x. And when I put this where I see the x, I'm going to do that order of operations, spit that y value out. That will give me the y value of the vertex. So this looks very scary, but all you really need to know out of it is this right here. To get your x coordinate, take this coefficient, divide it by 2 times that coefficient, and change the sign of whatever you got. Now recall that whenever we graphed our parabolas before, we said let's get that vertex, let's figure out which way it opens, let's use our x-intercepts and our y-intercepts to get the rest of the graph, and then we'll get that axis of symmetry. To get the x-intercept, you still make a y0. You're still going to take this, you're going to pull that out, put a 0 in its place, and then you're going to solve that for x. When you make this 0, this is going to look like a quadratic that you're used to solving. And most of the time you'll try to factor it. If it'll factor, and if it won't, then you can use your completing the square, which most people don't want to do, or you can use your quadratic formula. But if it'll factor, that's the easiest way to go. And then we need to get our y-intercept, and watch how easy this is. All I'm going to do is take that x, I'm going to put a 0 in the place of the x. So when I put a 0 here, what happens to that term? Absolutely, it's gone. When I put a 0 here, what happens to that term? Absolutely, it's gone. The only thing I'm left with is this right here. So whatever that c is, that's going to be my y-intercept. So that's fairly easy to deal with. I'll have my x-intercept, I'll have my y-intercept. Now remember, I do need to figure out which way it opens. Before, how did we figure out which way it opened? Certainly, if it was positive, we said, oh, that makes sense, that's common sense, it's going to open up. If it's negative, well, it makes sense, it's going to open down. That does not change at all. Now remember, when that came to that axis of symmetry, we said, okay, the axis of symmetry is going to be a vertical line. Every vertical line has all x coordinates the same. The x's have to be whatever the x is there. Now recall, this axis of symmetry always goes through the vertex. So therefore, whatever this x coordinate of the vertex is, that's going to be the x-coordinate for every point on the axis of symmetry. So all these x's will have to be whatever that is. And that will be my equation for my axis of symmetry. And remember, all I need to get to graph it is a vertex, figure out which way it opens, get that x-intercept, get that y-intercept, and the axis of symmetry I can get ahead of time, or I can get it afterwards. So let's take a look at one example of how to use this general form in order to graph my parabola. So I've got the equation x squared plus 8x plus 7. And what I'm going to do here is I'm going to figure out my vertex, figure out which way it opens. I'm going to get my x-intercept, my y-intercept. I can get my axis of symmetry ahead of time, or I can get it after I graph it. It doesn't really matter. Now recall, the vertex, I cannot eyeball it like I did when I had a parentheses. Remember, when it was in that standard form that you see right here, we could eyeball. And once you saw that minus, whatever that h was, that was going to be the x-coordinate of the vertex. Whatever this was, that was going to be the y-coordinate of the vertex. But in this case, I can't just eyeball that because I don't have that parentheses in there. So now I have to go through a few calculations. Those calculations being, in order to get that x-coordinate, I need to do that negative b over 2a. Now recall that when it's written in this form, the b is the coordinate or the coefficient of your x to the first power term. So I have a negative 8. My a is the coefficient of my x squared term, so it's a 1. So now I have a negative 8 over 2, which is a negative 4. That is the x-coordinate of my vertex, negative 4. And we said to get the y-coordinate, all you got to do is take that negative 4, throw it in here, do all that order of operations, and that will tell me what that y value is. So I'm going to take my function, I'm going to put a negative 4 everywhere I see an x. So that means I'm going to put a negative 4 right in here. I'm going to put a negative 4 right in here. And then I'm just going to follow order of operations, which says do the exponents first. So negative 4 squared is 16. After that, I'm going to do my multiplication. And 8 times negative 4 is a negative 32. And then after that, I'm going to do addition and subtraction, recalling that as a group, go left to right, whichever you see first. So I see 16 minus 32 is a negative 16. Negative 16 plus 7 will give me a negative 9. There is the y-coordinate of my vertex. So I know that in my graph, my vertex sits at negative 4, negative 9, 2, 4, 6, didn't go down far enough, 7, 8, 9. So negative 4, negative 9 sits right about here, so that means I'm going to have to slide that out of the way. Now I need to figure out which way this thing opens. Remember, I'm still looking at the a. I'm still looking at this coefficient of my x squared term. It's a 1, but more importantly, it's a positive 1. So if it's positive, remember, it makes sense. It's common sense. That's going to have to open up if it's a positive 1. So it's going to go like this, and I can see most definitely it's going to cross that x-axis in a couple of places. It's going to cross the y-axis over here somewhere. So I need to get those x-intercepts. Remember, to get an x-intercept, you make the y 0. So I'm going to take this y right here, f of x is acting like a y, pull it out, put a 0 in its place. Now when I do, I get this. And now what I'm going to do is try to solve that for x. This should look familiar. We were doing this a while back, and we said, okay, we got 4 options. We can either factor it, we can try the square root property, but we're certainly not going to do that here because we've got a first power term. It's not do the square root property if all you got to do is take the square root of both sides, or for that matter, slide something out of the way and take the square root of both sides. But I'm not able to do that here. I could complete the square, but nobody wants to complete the square unless you have to. And I could use my quadratic formula, but I'm telling you, I will go to my grave arguing with everybody around me. If this will factor, that will be faster than the quadratic formula. So I'm going to try to factor this. Now if it won't, okay, I'll go for that quadratic formula, but I'm going to attempt to factor it first. Now remember, you always look first to see if there's something common that you can divide out before you do anything else. There is nothing common to all 3 of these terms. It has to divide out of every single term. And it won't divide out of every single term. So I'm headed for this double parentheses. Remember, I'm going to eliminate half my guesswork right here. This tells me I have same signs. This tells me they're both positives. So I'll put a plus here and a plus here. I'm going to split this into these front slots, so I get an X and an X. And I'm going to split this into the back slots. The only way to split up a 7 is a 7 and a 1, but I want two numbers that are going to multiply for 7. They're going to add for an 8 because the signs are the same, and sure enough, 7 and 1 will add for an 8. Check out here. Positive X when I multiply, 7X when I multiply, and sure enough, X and 7X does give me an 8X. So this is the correct way to factor it. And remember, now's my zero product principle that says if I've got two things that are multiplied together to get a 0, one of these two's got to be the 0. I have this parentheses times this parentheses. These are the two things multiplied together to get a 0. So either this is the 0 or this is the 0. Now if this is the 0, X is a negative 7. If this is the 0, X is a negative 1. Recall that these are points in the 2D coordinate plane, so I need to put them in coordinate form. The X is a negative 7 when the Y is a 0, and the X is a negative 1 when the Y is a 0. So there are my X-intercepts at negative 1, 0, and 2, 3, 4, 5, 6, 7, and negative 7, 0. So I can see it's definitely coming up through here, coming up through here. So I need to figure out what that the Y-intercept is. To get that Y-intercept, remember that's where it crosses this axis, so that means make the X 0. That means up here, I'm going to take every one of those X's out and put a 0 in its place. So I'm going to take this function right here, put a 0 where the X is, and then when I do, I get 0 squared plus 8 times 0 plus 7. Beautiful, because this is now 0 and that's now 0. So what I really have is 0 plus 0 plus 7, which is just a 7. So that means it crosses that y-axis at 7. It's a point in the 2D coordinate plane, so I need to put it in coordinate form. Coordinate form said, well, when the x is 0, the y is a 7, because I made the x 0. So that crosses at 1, 2, 3, 4, 5, 6, 7 right here. So it's going to go like this right up here. And then remember, I can use symmetry to get the other side. So I kicked back, let's see, I was at negative 4, and I kicked back to 0. So that's 4 spots. I'm going to kick back another 4, so I'll go back 1, 2, one more here. And then go right up here to 7, which is very difficult to show. I am not providing myself much room on these graphs, and I so apologize for that. So it's going to look kind of like this. Oh, terrible, terrible job. But hopefully you can see loosely what that graph looks like, and good grief, I really need a good laugh. So let me go ahead and put that smiley face in there just because it makes me happy. So that gives me my vertex, which way it opens. I've got my x-intercepts. I've got my y-intercept. I use that symmetry idea to get the rest of it. I just need that axis of symmetry, which recall goes right here through that vertex. So I need to see, and I think I just didn't mark that off very well. I think I did not do a good job on that vertex, is why my graph looks so funny. That's a little bit better. And it goes right through this vertical line, right through here, going through that vertex. And remember, if it's a vertical line, that means that every one of these x-coordinates is going to be the same, because every one of these x-coordinates, left or right, it's all the same. So on my axis of symmetry, all those x's have to be the same thing. They are all that x-coordinate of that vertex, which I see right there is a negative 4. So like I said many, many times, I can get that axis of symmetry before I ever graph it by looking here and saying x is going to have to be whatever that is, or I can get it right after I draw the graph. And so this is how you graph your quadratics when they are in this general form. Hopefully you're seeing that it's the same processes, kind of, to that standard form. In other words, I need to get the same pieces of information. Still got to get that vertex. It's just how I get the vertex is different. I need to utilize this negative b over 2a. So if I can keep this memorized and just plug those numbers in there, that'll give me the x-coordinate of the vertex. Take that, plug it back in to get that y-coordinate of the vertex. Figuring out which way it opens is the same as it was before, because it's just going to be this a that's right here. If it's positive, it goes up. If it's negative, it goes down. Getting an x-intercept still means make the y 0, so I'm still going to take this right here and I'm going to turn it into a 0 and try to solve that. 9 times out of 10 it'll factor. If it doesn't, go for your quadratic formula. Get that y-intercept, meaning make the x 0. This is the easiest part of the whole thing, because you throw zeros here and here, the only thing left is right there. And so that's very easy to get that y-intercept. And remember, the axis of symmetry cuts right through the vertex. Every one of those x's are the same, so they're all going to be whatever that x coordinate is. So hopefully that helps, and have a great day.